Today we are presenting on scaling with NoSQL, a topic that explains how modern systems handle massive amounts of data efficiently. Traditional relational database were once the only option for storing ex- structured information. They work well when applications were small, but a system grew. This database hit serious limitations, scaling them meant buying more powerful and more expensive servers, which is known as vertical scaling. This approach quickly becomes impractical because there is a limit to how much one machine can handle. To manage data, to manage data, to manage data, to manage data more cleanly. Relational database used something called data normalization. Normalization split data into multiple tables, reduce redundancy, and ensures integrity using primary keys and foreign keys. It helps with consistency and indexing, which is greatly more small application, but one of the system grew. The approach becomes problematic. Normalized data requires many jobs. Many joins and joins become very slowly when data has to be distributed across multiple servers. So while normalization improves quality, it makes horizontal scaling far more difficult. This challenge is what see the stage for newer approach like NoSQL, which we will explore next. Moving forward, let us talk about the turning point that led to the rise of NoSQL in the early thousands. Major companies like Amazon, Google, and Facebook start facing massive scaling challenges. Their user bases grew into the millions, creating huge read and write loads that traditional SQL database simply could not handle ACID transaction and stick schema rules became bottlenecks, freeing themselves companies from scaling globally. To solve this, they built their own distributed system that focused on speed, availability, and handling huge data set efficiently. Use data set efficiently. There's better innovation lead to the of NoSQL for movement. Google published papers on GFS, MapReduce, and Big Table, and Amazon introduced Dynamo, which later inspired many open source systems. This is how database such as MongoDB, Cassandra, Redis, Rig, Cassandra Revic SQL is standard for not only SQL, meaning it is not a replacement for SQL but an alternative model that removes some relational limitations. A key concept in this area is mindset track of NoSQL. NoSQL system do not try to give you every feature that relational database offer. Instead, they focus on what matters most of scalability such as availability, low latency, or partition tolerance. To achieve this, they sacrifice stick consistency, avoid complex joins, and allow denormalized data. These delivered trade-offs enable true horizontal scaling where data can spread across many servers efficiently. Efficiently. Now, CAMP theorem, the theorem which is a central understanding in NoSQL system. CAM state that is in distributed system, you cannot guarantee consistency, availability, and partition tolerance at the same time. In other words, when a network failure happens and the system becomes partitioned, it is impossible for every node to respond while also ensuring that all nodes has exactly the same data. This is why the famous phrase FICO. pick to became associated with NoSQL while not perfectly the became associated. Accurate highlights that real world system most must use their partition. The diagram of the slide illustrates this when there is a communication failure between more nodes, different versions of the same data can appear on one client may update the price 299 while another node says the price 75 says the 75 has conflicting rights, so why a distributed system must make a trade force, for example choosing availability and partition tolerance while allowing temporary and inconsistency impact of CMP and NoSQL today. Today database for large scale applications such as social media platform, e-commerce website, IoT systems, and real-time IoT system and real-time analytics tools. So they use technique like replication, sharing, and consistency to stay fast and doesn't replace SQL. Instead, it offers another power tools for a system that handle huge volumes of data to use volume of data. Conclusion: scaling with NoSQL it is about selecting the right priorities based on your system needs. So whether that is in consistency, availability, performance, or simplicity. Thank you all for listening. Any question?